Hi everyone, welcome back to Hard Problems Made Easy. Today we are going to look at merge case sorted lists. So we are given a bunch of linked lists and we are expected to return a linked list that is in sorted order. So we are supposed to merge these sorted lists in order of n time. So let's look at the visualization. So we have the bunch of lists here. These are the input lists. Each list is sorted in itself. So we are looking at having it merged and then putting it here in the result island. So we use a min heap to achieve this, and we also have a staging area for popping the top of the min heap. The first step is to add all the lists to the min heap, right? If you look at the yellow boxes, that is the very first element of each of the lists. So we are having the heap. Let me go a step back. We are having the heap in the order of the very first element, right? So here in this list, the first element is 0 and that is at the top of the main heap. So we will be like popping that list, taking the very first value and then putting it in the result. But before we move this, in here, right, we are actually having a dummy head, dummy pointer, so that we can go and add this list here. So initially both, let me zoom in so that it is clear here, right? So there is this one list node where both the dummy and the tail is pointing to the same. Now when we pop the very first element and then put it into the result list, the pointer to the tail will move. Okay, now we have this list here. We are going to again push it to the heap. But here it sits at the bottom of the heap since the value of the first element here is bigger. Right? So now we look at the top of the heap, pop it, pop the very first element. Remove the very first element and then link it to the result. Now we put this back into the heap. Okay, we move the tail pointer. Now we put this back into the heap. Right? Likewise, we keep popping the top of the heap, taking the first element, putting it in the result, and then putting the linked list back. Right? Take the list, take the top, move the tail pointer, and then put the list back. Right? So now we get the idea on how this program is panning out. Right? So the tricky part is that we are looking at having linked list. This would have been much easier. It was an array, but since it's a linked list, the comparison part is a little bit tricky. Let's go to the code once the simulation is completed, and then we look at the code so that we get a better idea on what's happening. Okay, the standard solution is that we first have to deal with how we want to do the comparison of two list nodes. Right? So when we are looking at pushing these linked list to a heap, we need to tell the heap how to compare two list nodes and say which one is lesser and which one is greater. So there are like multiple ways of achieving it. I've taken the most simplest approach that we have found, which is you override a lesser than, right? So in this class we override a lesser than and say that self dot value, if it's lesser than whatever is the other dot value, then we give true, basically the boolean true or false, right? So there are also other variations of this. One variation that that is very common is that instead of like pushing the head of the list into the min heap, right, what we do is we push a tuple that has the value of the top of the list, and then an iterator, say the index of this list, something of that sort, or a generic monotonically increasing iterator, and then the pointer to the node itself, right? Instead we are just taking the most simple solution. We just add this one line that adds a comparison method for list nodes, And so that we don't have to pass a tuple, we can just straight away pass the pointer to the list node directly, right? So that is this part, right? So we add to the class so that it makes our life easy. And then we initialize a min heap. We push all the linked lists in the input into the min heap, right? And after that, we initialize a dummy that we saw in the visualization. You know, we initialize a list node, and then we have two pointers. The dummy pointer also points to this. The tail pointer also points to this list node. Okay, so that is what these two lines are doing. And when we reach this program, this part of the code, we already have like all the inputs, heaped up into our main heap, and then we keep popping the top. We pop the top, and then we link the tail to the first element here, and then we move the tail to that element like we saw here, right? So we could go to that again quickly. Yeah, so let me go a step back. I like went too fast. So what happened here is that whatever was the top here, we are going to link it, right? So the tail dot next becomes the smallest node, and after that the tail itself becomes tail dot next. Okay, after this is done, if there is anything remaining in here, which is so here we do have the rest of the list remaining, we will be like pushing it back into the heap. Okay, so that is what is given here. And again, we are going to look at popping the top, and it proceeds till the heap is empty and the result list is fully generated, right? So let me play it out, right? So we keep pushing the top, we keep pushing the top element of the popped list in here till the result is like fully completed, till there is nothing left in the heap, right? Let me speed it up a bit. I don't think it has speed up anyway. So we have this last list. We're going to wait for it to complete, right? Now the tail has reached and the heap is empty. In the end, what we do is this dummy we will ignore, and then we will return dummy dot next, which is the actual sorted list that we have to return. So that is the code. Hope this was helpful. See you in the next video. Thank you.